In our first video on acids, we saw how a Coke can reacted with In our first video on acids, we saw how a Coke can got destroyed when we poured acid in it. This happens because when you take a metal and you add it to some acid, so say for example, we have a test tube, like aluminium, what this is, it will react to form a salt and hydrogen gas. So all the fizzing and the bubbling that you've seen happening was actually a gas called hydrogen being produced, H2. So H2 gas was produced and all that fizzing and bubbling. And then the Coke can, the metal seems to disappear. And that's because the aluminium is forming a salt, which then dissolves into the acid. So you don't see it anymore. It's not that it disappeared. It's just that the substance that was formed is now dissolved into the mixture. That substance is called a salt. Now, let's swap out the aluminium and look at a different example. Let's say, for example, we started with the metal calcium. Now, if we took calcium and we added some acid, for example, battery acid or sulfuric acid, what we would find is that it reacts and it produces calcium sulfate, which is a white substance, but it's soluble, so it would disappear as it's made. Plus, it would fizz a lot and it will produce hydrogen gas. Now, if we look like this, so Ca is calcium, sulfuric acid. What we would see then is that the calcium swaps places with the hydrogens. So the two hydrogen ions that we've seen before this, okay, the two hydrogen ions, they fall off the acid, as we learned about what acids do. So the acid donates 2 protons. And what happens then is that the calcium sticks to the SO4 bit, the sulfate, to form calcium sulfate. See, it has swapped places with the hydrogens. The two hydrogen ions then combine to produce H2 hydrogen gas. Okay, so this is a typical reaction anytime we add a metal to an acid. So much so that this always happens, which means that we can actually write a general equation here. We can write down, we can write it down like this: metal plus acid. Also saw aluminium was a metal and it does the same thing. So in fact, we could take any metal from the periodic table, this of a metal and a non-metal ion combined, plus needed to produce some hydrogen gas. This is one way you could do it. Now, it wouldn't be that efficient of a way because I suppose you're using up all your metal and it's gone then. So you'd have to keep adding more metal, more acid, more metal, more acid. So you could do it like this, but if you want to produce hydrogen on a large scale, this would be very limited because you'd have to add them, keep adding them together. So there's other ways you can produce hydrogen, which will be more efficient than this, but you could do it like this. Now, as you can see here, the hydrogens from the acid have been replaced by the calcium. Now, the salt is called calcium sulfate in this case. Now, the reason why it's called sulfate, well, obviously it's called calcium because there's calcium in it. The reason it's called sulfate is because of this bit at the end. This is the sulfate ion, depend on what the acid was. Because here, as you can see, this is the ending or the end bit of the sulfuric acid. But what if it wasn't sulfuric acid? What if it was a different acid? So say, for example, it was calcium plus, now this would be HCl. So here we would have calcium plus chlorine, okay, or plus hydrochloric acid. And this time, chloride. It comes from the ending of the acid name. So if it's hydrochloric acid, then the name of the salt will always be whatever the metal is. It could be sodium, it could be potassium, whatever it is. It will be calcium chloride, potassium chloride. Okay, so I suppose a good rule here is that hydrochloric acid produces chloride salts. We already seen that sulfuric acid produces sulfate salts. So sulfuric produce sulfates as the salts. And the other one then would be nitric acid, is produce nitrate salts, nitrates. Now, the other products will always be the same. We'll always produce hydrogen gas so long as it's a metal and an acid. And then the name of the salt is really the only hard bit. If it's hydrochloric, it will be something chloride. If it's sulfuric, it will be something sulfate. And if it's sorry, not nitrate, this should be nitric acid. If it's nitric acid, it will produce nitrates. All right, so that's really the hard bit, and that's what we are going to get into over here. So we're going to look at question 54 now, and we're going to see how this works. So the first one has been done for you. It's asking you to complete the table below. The first one's been done for you. Notice that we're starting with the formula of the salt, and we want to name it. So this here is sodium chloride. Okay, so chloride is the name of the salt, and the metal is sodium. So sodium chloride is the name of the salt. So what did the original metal have to be? Well, it had to be sodium, because look, that's there. And then what did the original acid have to be? Well, we learned already that if it's metal chloride, like it is here, chloride, then it had to be hydrochloric acid was the original acid. So what I want you to do now is I want you to copy the table out, and I just want you to do the second line, please. So just this line now, I want you to do underneath, and we'll see how you get on. If you get it right, then we can do the next three. So pause the video, do the second line. All right, so hopefully what you did here is you said that this here was called lithium chloride. That's the name of the salt. Again, you might have to go to your periodic table, find Li and find Cl. So what was the original metal? If you didn't get this right, I want you to pause the video and finish it off now. All right, so what you should have done here is the original metal is lithium. That means that the original acid had to be, again, hydrochloric acid. That right? Well done. If you got that right, you're ready now to pause the video and have a go at the next three, please. Pause the video, do that now. Okay, so naming the salts. This one would have been calcium, because that's the name of the metal, and it's calcium sulfate. Okay, well done. I'm going to do the rest of these down to the bottom, and before we do the original metal and the original acid. This one should have been magnesium sulfate. The name of the last salt would have been potassium nitrate. If you got them all right, then well done. I think you would have got all the rest of it right too. If not, I want you to fix these now and then finish this, and this. All right. Pause the video and do that now, please. Okay. No, sorry. Get rid of all of these. All right, so let's finish these off now then. All right, so the original metal here would have been calcium, is the metal. And if it's a sulfate salt, then it would have had to be sulfuric acid. If you got that right. The next one would have been magnesium as the metal. And if it's a sulfate salt, it would have been sulfuric acid. And if it's potassium nitrate, then it's potassium as the metal. And nitric acid was the acid. All right, I'm going to pause the video at this stage, and we are going to look at this here. So the line here that's in green, this might be something that's important to take down. So this here shows the reaction between a metal and an acid. We'll pause the video, take that down. And then this here could be your example of that underneath. So pause the video, take that down. Okay, so hopefully you understand all that stuff. I'm not just blindly asking you to take it down. But that there is important because it's always true. Any metal and any acid will always produce a salt and hydrogen gas. Okay. All right. So we should now be ready to write some equations for those. Okay. So let's have a look at 55. I will do A with you. Okay. I will do A with you and we'll do them together. So first of all, we're writing a word equation. Now we should know what a word equation is from back when we were doing chemical reactions. Looks something like this. We write the name aluminium. Reacts to give. So this arrow means produces, so turns into. And now we have to name the salt. So it's aluminium and it's chloric acid. So it's aluminium chloride. And it's so now that I've shown you how to do the first one of those, A, you're going to do B, C, and D now. Pause the video and do those now. Okay, now what we're doing is we are working backwards. So 56, we're going to write a word equation for the reaction which forms aluminium sulfate. So where this is the salt, I wanted to write the reaction. So doing that for this one, actually, I'll do this one with you. Okay, so let's start. And it reacts to gives hydrogen. So I'm going to write that down now. It doesn't really matter what order you do these in. I'll do this here. And I'm thinking about what was the stuff involved. What were the reactants? Well, my metal here is aluminium. Okay, and then we have sulfate was the name of the salt. So if it's sulfate. So again, see how that works. What I want you to do is pause the video and finish down to H, please. Okay, so what I would like you to do at the very last is try and write a balanced equation for that last one. So write a balanced chemical equation for this last one. So what you should have said is sodium, which is Na, okay, plus hydrochloric acid, and then tell me about the salt it produces and the final product. So pause the video if you haven't had a go at this. You're writing this out now. You're trying to write a balanced chemical equation. Pause the video, do that now. Okay, so what you should have done is Na plus HCl is hydrochloric acid, produces sodium chloride, which is NaCl, plus H2, which is hydrogen gas. Now that there is where you could have gone wrong, okay? To balance that, you could have said just H at the end. But this is wrong because hydrogen gas is H2, it's a diatom, okay? So if you just left it as H, then that's not right. It has to be H2. Okay, so that has to stay 2. All right, so then we got to balance all the rest to make it right. So here I see 2 H's and here I only see 1. So I'm going to put the 2 here to balance that out. Okay, so if there's a 2 there, that means I'm going to put a 2 here to make there be 2 chlorines here and then a 2 here. All right, so that there is my balanced equation. 2 NAs plus 2 HCl give me 2 NaCl plus H2. So that there, I think we are done with our reactions of acids with metals. All right, so an important little one there, because little questions come up here and there, and this is the small little detail which some teachers can forget to cover or students forget to study, and you can miss it very easily, and that can take away your 10 or 15 marks of a question that you want to do. All right, guys, that's it. So I shall see you in the next video. I hope you found this useful. If you did, please like the video, and let's get this out to more students who might be struggling. Thank you, guys. We'll see you in the next video.